Hey everybody, this is Larry. Merry Christmas, Happy Holidays, all these good things. This is day 25th of the Decode Daily Challenge. A little bit late today, it is, a medium problem today. A classic problem, Decode Race. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I forgot to turn on the lights today. Okay. But yeah, today's problem is Decode Race. So let's take a look. Which version is this? There are a couple of variations of this, so I have to check. Okay, so basically you're given a number or a string of numbers and trying to try to decode the number of ways to change it into a string, right? All right, let's do this. I think at the core this is a dynamic programming problem. This is I used to say this is like relatively tough, but I think nowadays, especially if you do enough code force for sure, but Leetcode and competitive, it is pretty much table stakes at this point. And to be honest, I have had colleagues ask this question or variation of it, like as I said. So it's definitely in scope. I don't like it per se because it feels a little bit too meh for me right nowadays, but definitely, like I said, I've known people to ask this as on the interviewing side, so it's not even just like hearsay of like one off or whatever. But all right, but the idea is there are a couple of ways you can write this, of course, many ways you can write this, of course, but the idea here is just to write with dynamic programming is about rephrasing a problem in terms of the subproblems. And the subproblems in this case will be the suffix of the string that you're getting. Right, so basically, that's pretty much the idea, and you see it maybe represented in number of ways, but that's basically the core idea, right? And if index is equal to n, that means that there's no zero with string left, so that means that you have one way to decode this, and that's just the way it goes sometimes. And then now you look at you try to figure out how to break the current suffix down, and there are a couple of ways you can do this, right? You can either take one character or two character. It really seems like, I guess this, because I guess there is a variation with a wildcard, like a question mark or a star or something like this, and that kind of makes things a little bit more complicated. But really, this is pretty straightforward in a way, right? So if this is equal to oops. So basically, let's say we do one character or one character. Right? If the one character is between a 1 and a 9, because you cannot do a 0 by itself, then we can return count. Oh, it was not return, but it's just sorry, friends. You can try to just use one character, right? So this is an A to, I don't know what 9 is. A, B, C, D, E, F, G, H, I. Yeah, I mean either way, should be okay, right? So then now it's two characters. So if so it has to be between 10 and, is it plus 2? And 26, is it? Is it 26 or 25? 26, yeah. It's very easy to get off by 1. Then now you do, and then now you try to get how many counters there are for the suffix of that. And that's pretty much it. And if you kind of think about it, this is very so yeah. Okay, let me actually finish writing this. So then the first thing you may notice is that let's say we don't memorize, we don't do dynamic programming. What is the complexity, right? You may be tempted to say it's 2 to the n, but it's actually slightly better than that. One way to kind of bound this, and 2 to the n is probably fine, because I think if you do the curve, 2 to the n is going to be higher than it. But But actually, if you kind of look at the best possible case, this is actually going to resemble Fibonacci. And Fibonacci, of course, if you may know or may learn about, is actually phi to the n, where phi is about like 1.616 or whatever it is, right? So slightly better than 2 to the n, but still going to be exponential. And in that sense, then now you're like, well, let's make it not exponential. And this is where you do repeated subproblems. And there were different ways that I sometimes use to describe repeated subproblems. Wow, I'm screaming because I'm covering my ears and I couldn't hear myself that well. But anyway, the one thing is just thinking, okay, index and go from 0 to n. And for every input, you put in the same input, it reaches the same output, right? Given that it's index and s, I guess if you really want to be precise, it's something like index and s, say. Right, but S doesn't change, obviously, and in this case, you're like, well, yeah, given the same input, you get the same output, so let's save it down, and that's how we usually do it. I usually write it this way, and it's been a while, I guess, because we've been just doing easy problems in December, right? But I usually write it this way just so that it's easy to kind of see. You don't have to write it this way, and I don't even know that I would recommend writing it this way, but it's just for more the beginner of us, because I think it's easier to kind of separate out these things. So you can certainly write these things in a way that encodes different things at the same place, and that's what people usually do. But this is how I choose to teach it. So yeah. And basically that's it. And now we could give it a submit. And there you go. 1365. Apparently I solved this like 8 times already. Not 8, but like 5 times. Why did I get wrong answers? Was I using C or something? No, I don't know why I guess I try to be too cute with all these things. In parsing, and nowadays I guess I'm a little bit more I was trying to be too cute, but yeah, nowadays I think I just kind of more practice with Python, because that was look at that time though, 2019, that was 5 years. What year is this? Okay, it's only 4 years ago, but I forget what year it is sometimes. Happy holidays, everybody. But yeah, as I said, what is the complexity here? Well, there are n inputs. Each input takes all of 1 time, because these are all just lookups, and each input takes all of 1 space, so this is going to be all of n time and all of n space, right? And that's pretty much it. Gonna call it, just call it, because it is holidays. I'm gonna get back to my holidays, but yeah, that's what I have. So stay good, stay healthy, to good mental health. Ooh, excuse me. I'll see y'all later and take care. Bye bye.